Okay, let's start with our process. The earlier part we did on a triangle. We'll hit the ground running just to wind up things a little faster because we know what triangle is now. Let's not forget Von Hiele. We mentioned Von Hiele first. Von Hiele gave us a very good framework for developing geometrical thinking. And his first process is recognition. Does the learner recognize things? The second process is, does he know about the properties? The third and next processes are, I'm not slavishly using the same words, but you can always dig it out on the internet, is about relationships, its connections to other relevant concepts. And the fourth, then we come to analysis phase. So that's how gradually we go down. To recognition phase, we already did it. Yes, when a triangle can be made and when it does not make. But just for the sake of it, we can ask the child, is it a triangle? He will say yes. Is it a triangle? He will say yes. And once that concept is understood, well understood, it's always good to a little bit extend the concept so that they clearly know what is not a triangle as well. Is it a triangle? No, it's not. Is it one? No, it's not. But is it one? Maybe, maybe not. And he might get confused. Is it a triangle? Is it a triangle? It has three sides and three angles also. Technically, this is also a triangle. Technically, all these four that I have kept here are triangles. But these are not the triangles that we are talking about. Technically, this is also a triangle. I have taken it out from a sphere. This is also a sphere. These are spherical triangles. These are circular triangles. There's no harm that we give an opportunity to the child to peep into the future. Oh yeah, there's even more interesting things coming, right? But our discussion now is about the triangles, which is flat with straight lines, straight sides, etc. Good, fine. So we come to properties now. We did some properties yesterday. A bit we move forward. One property that we did with the triangle was that any triangle, very interestingly, now we can fold it from half and we can fold this thing into this kind of a rectangle. And that proved when we did it by folding paper. Fine. But there's an interesting extension of it. We can, if we take this part over here, it will come here. If we take this part over here, it will come here. So interesting, we can make a triangle into a rectangle. So these kind of transformations are very important. We learned that triangle can tessellate anything. Triangle can make any stuff. It can make this, it can make this, and then tangrams you can use, give the child to make huge lots of different stuff which they can keep experimenting with. And this journey is never ending. So that's one part on the properties. Our favorite triangle was this, because it's very easy. Three triangles will remain our favorite. One is this, and another two are 30, 60, 90. 30, 60, 90 triangle, and another is 45, 45 degree triangle. Two sides are equal. Why these are favorite? Because these are the most used in our common applications in the daily use. This triangle is very easy for us to deal with because finding its area is very easy. And we said any triangle can break itself into right angle triangles. So the right angle triangle is an easy to draw area with. But a little bit, let's dig more into the interesting properties of the right angle triangle as well. There are many, but a few that we can quickly inspire the child with are, let's take the half of it, the midpoint. Very interestingly, this midpoint is equidistant from all its three corners in a right angle triangle. What does it mean? That means interesting stuff. That from here I can draw a circle which can fold the triangle in itself, circumcircle. Interesting, isn't it? Yeah. And quickly, one more thing about this, our favorite triangle, which is sometimes they call it RAT as well, right angle triangle, let's say call it RAT, is that if I drop a perpendicular from here to its hypotenuse, hypotenuse is the longest side, hypotenuse means it's in the tension. It's always tell a little bit meaning of the name that connects, right? How many triangles are these? 2. No, these are 3. The children and the parent itself. All these 3 triangles are similar triangles. They follow the same ratio in corresponding sides and angles. These 2 are similar triangles because its angles are same. But these are not of the same size, right? These are not identical. For the identical shapes, we call they are congruent. Congruent means they are in harmony with each other. They just fit upon each other. So these 2 are congruent. Yeah, even if I keep it like this, but through manipulation, through translation, through flipping, if it just fits over it, I will say it's congruent. So congruent and similar are the words, the terminology. It's always names, standard names are vehicles for communication, so that whenever we call it by standard names, it connects us faster to the person we are talking to. One more name is important which comes to mind is, let's say, if I drop a line from here to anywhere opposite from any vertex, what do we call it? What do we call it? Cevian. This line is called Cevian. Cevian, Siva was also a mathematician. He has there is a theorem in his name as well. So any line, it can go in the middle, and we may call it median, but it can come with a 90 degree, and we call it drawn a perpendicular. But all these lines are Cevians. So that's probably the name I thought maybe it's good to know it. In my journey, this name actually never came. Median came, but the general name Cevian didn't come. So angles, we will discuss it when we actually started from the point to line in our series. But some angles are like this and some angles are like this. Now this angle is very sharp, like a knife, but this is blunt. For the sharp, we have a word acute. So it's acute. Acute means it is sharp. And the opposite is then very easy. The opposite is blunt, but instead of blunt, we are calling it obtuse. Once we know acute, the obtuse is obviously opposite. So from here, we move onwards to a little bit of relations of which a triangle has among themselves. Whenever we classify things, if you ask me how many are the types of the triangles, and you ask any children really, they get confused. There are so many. This is isosceles, this is equiangular, this is what. At least I got confused. That's why I'm telling. Taking myself as an average student, I got confused. Okay, how many different types are? Can I write down? Principle, step back. Principle is whenever we classify things, we have to know that we have to classify by some property. Triangle has 2 properties or dimensions. Dimensions are its sides and dimensions are its angles. Simple. Okay. By angles, I can say maybe it has an obtuse angle, the blunt one, greater than 90, or it has a right angle. Then I place it in a mental folder. It's a right angle triangle, and I may say it has all its angles are acute, so we say it's an acute. Or if all angles are equal, we can say it's an equiangular, right? So on angles, I can see like this. From sides, you can ask children, how will you see different triangles by their sides? And in 5 minutes, they will discover, oh, sides can be equal. All 3 sides equal, can be. 2 sides can be equal. Yeah, what else? None is equal. Is there any other possibility? And they'll quickly find out, no. Later, we can always tell them names of all these things. If the concept is understood, naming always helps. Sometimes we start with the standard names. Sometimes it's better to give the concept first. instead of confusing with the name. For example, sine, cos, tan are confusing, but if you tell them just the run and rise, it's easy to understand. Equal, probably we call it, we call it equilateral. This we call it isosceles, this we call it scalene. Now, leave them with some question. What pairs we can make which are legitimate and make sense? Can there be equilateral acute? Can there be isosceles right? Can there be scalene obtuse? And for each, ask them why. Why do you think it's possible? It makes sense. Very interesting activity. And it's the why question and what if question always give them deeper understanding of the things, because they are able to then explain why. Another question that comes to my mind and was always confusing was, what is center of the triangle? What is center of the triangle? Right? Give them and they will come up with answers. Then you can tell them, we can find out actually center in so many ways. Let's say this is the triangle. We can take the midpoint and find out the centers to the opposite side. Yeah, this is also a center. What we can do is we can draw a perpendicular also on the opposite side. And interestingly, this also meets at a point. We can, what else we can do? We can bisect the angles on each side and see even this is also meeting at a point. And what else we can do? We can, one more possibility is that we just take the midpoint and from there we go at a 90 degree. Yeah, we can do that. So these are 4 different ways to find a center. And there are 4 ways to find a center of the triangle. They might be overlapping and they might not be, depending on how a triangle looks like. But this gives a very interesting property. Very interesting property. The one which is this one, for example, which is the median, which is touching over here, it will be very interesting that we can draw a circle inside. That's why it's called in center, right? And this one will help us draw a circle on the outside. We will touch all these. So we call it circumcenter or This is circumcircle and circumcenter. This is in circle and in center. This is the point where the children will start enjoying this process. This is, since it's coming straight means one of the word for straight is ortho. So this is orthocenter. And there is some name for this thing is it is centroid. It is centroid. It touches the median. Now, centroid has its own very significance in mechanics, in physics. Centroid is the one where I can actually balance the triangle. This is the centroid. So that's how we should make connections. And you will, when they make a triangle and do it, they will find out a very interesting thing that I did to save time. 3 of them will always, when you give it to different groups, you will find 3 of them will always be on one line. Euler, the prince of maths, discovered it, and we call it Euler's line. This is interesting, right? And few more things that we can talk about, because look, George Polya, don't forget, George Polya. He is said to be the father of problem solving. He said, if you want to teach a concept, know the concept. His second rule was for teachers, if you want to teach a concept, you're supposed to teach one, know a little bit more about the concept. So it's always good to know a little bit more of the things what we are doing. There are lots of stuff and unending stuff, this journey never ends. We read a formula of this kind, the triangles, at least the right angle triangle, this triangle can be. Easily we can take A into B, since this is the formula of this, over 2. Later in the coordinate geometry, etc., many different interesting formulas of the areas will come to. Essentially, area is all about counting squares, unit squares. Squares can be in it. Are you aware of box method of area in triangles? I hadn't heard of at least. This is the box method. Let's say this was the triangle given to me, right? It was a little difficult to find out this by Pythagoras and all that. But what can I do with? Put it in a box, find out the box around it, and it's very easy for me. This is 2 into 3, half of it. This is 3 into 5, half of it. This is 3 into 6, half of it. So I can find out area of the externals and subtract from the box. So it's a very interesting journey which is inspiring. And as we earlier said, what connects is do lots of play with it. There's thousands of things you can do with it, right? As simple as drawing a fish with it to as simple as making aeroplanes. And it will connect to architectures. When the children will see, oh, triangles is everywhere. It will connect them to the nature and the patterns of the universe, and that connects to the creator and the divine wisdom. Thank you very much.